We in mathematics, we like to look at shortcuts all the time. And so in this case, when we look at logarithmic functions, we're looking for properties that will always work if we're dealing with a logarithmic function, just like you had properties for exponents, or you may say rules or laws of exponents. Well, these properties for logarithmic functions will actually be very similar. Now, first of all, let's consider the first of the inverse characteristics that we looked at several lessons ago. If we have two inverses, f and f inverse, if we take their composition, f of f inverse of x, we will get x. So in this case, we're going to let f of x equal b. Then, remember, by definition, f inverse of x will be log base b of x. So if I take f of f inverse of x, then we're taking f of the log base b of x. But what does f do? F takes b to whatever the number is in parentheses or expression in parentheses. So this is going to be b to the log base b of x. But remember, since this is f of f inverse of x, that expression simply is equal to x. Therefore, we come up with what is our first property of logarithmic functions. It's called one of the inverse properties. If I take base b to the log base b of anything, it's equal to the anything, in this case, x. I had an algebra teacher once that liked to say something like b to the log base b of Sam is equal to Sam, just to say it doesn't make any difference what we have as the x there. Now let's go to this from the other composition. Now we're going to keep f of x equals the log base b of x, and remember that means f inverse of x equals the log base b of x as well. And remember that f inverse of f of x is x. So let's take f inverse of f of x. Well, f of x is b to the x. So I'm looking at f inverse of b to the x. But remember, f inverse of something is the log base b of that something. And so the f inverse of b to the x is the log base b of b to the x. But since these are inverse functions, that expression must equal x. So we get then a second inverse property, and that says if I have the log base b of b, remember that's the base of our exponential term, to the x, we get x. Now, let's look at that as an application. 3 to the log base 3 of 12 is simply 12. Or the log base 3 of 3 to the 12th equals 12. So we've got two properties that come in very handy at certain times. And those are called the inverse properties of logarithms. But there are three more properties of logarithms that are important as well. The first property says that the log base b of x times y equals the log base b of x plus the log base b of y. Notice logarithms take multiplication and turn it into addition. And that was important years ago before we had graphing calculators, because if we could take a multiplication problem, turn it into an addition problem, our work would be easier. And in fact, when I was in college, back in the medieval times almost, we had slide rules and instead of calculators. And slide rules are based on logarithmic functions. So let's get back to this one and take a look at it. In this case, the log base b of xy equals a log base b of x plus a log base b of y is not really too surprising if you think that if we had b to the x times b to the y, in exponential rules, what do you do with those exponents? And you're correct, you add them, just like the addition in logarithmic functions. Well, when I have b to the x over b to the y, what do I do with those? That division becomes b to the x minus y. You'll have a counterpart in logarithmics. The log base b of y divided by x becomes b to the x, log base b of x minus the log base b of y. Notice once again we've turned division into subtraction, a more simple operation. But by far, for our purposes, the most important of these three properties is the last one. We will use it repeatedly when we solve exponential equations. And in this case, let's look at this. The log base b of x to the n equals n times the log base b of x. Notice it takes the n out of the exponent. And that's not surprising if you remember that logarithmic expressions undo exponentials. And that's going to be a point that you want to keep in your mind, because when we solve exponential equations, we're going to use logarithms to help us out there. Okay, let's practice some with some problems. There are two types that we're going to look at. The first one's called expanding exponential expressions. And so when you do your homework or you encounter this on a test, it's going to say something like, here's a logarithmic expression, single logarithmic expression, expand it. Well, we're going to use our properties to expand this single logarithmic expression. I'm taking the common log, log base 10, of x squared y. Well, that's multiplication. Remember, logarithms take multiplication, turn them into addition. And so my first step will say that this is the log of x squared plus the common log of y. But I'm not finished yet, because I can deal with this exponent by rule number 3, or property number 3. And we can make that 2 log x plus log y. That is by our third property of logarithms. Okay, and now that one is expanded as far as we're going to be able to expand it. But notice we've got from one logarithmic statement 2 logarithmic expressions added together. Let's look at this one. We've got the common log, or log base 10, of x y to the 4th divided by y to the 5th. And so I can use my second logarithmic property and say that this is the common log of my numerator divided by minus the common log of my denominator. And again, that is by property 2. Now I can use properties 3 and 1 again to further expand this into the log, common log of x plus the common log of y to the 4th, but I can pull the 4 out in front, and then I can pull the 5 out in front by property 3. And so by properties 1 and 3, we get our final answer, the common log of x plus 4 common log y minus 5 common log z. Now, you should be getting used to this now, because we've been doing it constantly. If we do something in math, we want to very often undo the same thing. So we just expanded logarithmic functions or expressions, it makes sense now that we will say, let's take those expanded expressions and put them back into a contracted form. So, as we look at a couple of examples here, we're going to be contracting logarithmic expressions. We have a logarithmic expression, the common log of x plus 2 common log of y. Now we're going to reverse the process. I have 2 logarithmic, and it's important here that our base is the same. And remember, that's base 10 as we're looking at it. And since the base is the same, I can take that addition and turn it into a multiplication. And so it is actually, before I do the multiplication, I need to deal with this 2. I can make it my exponent, and that is by my third property. Now I can take my addition, it's a little ahead of myself, and turn it into multiplication. And our answer will be the common log of x times y squared. Let's look at another one of those. Let's say that we have 6 log u plus, in brackets, and the brackets are important here, 4 log v minus 3 log z. Now, it is in all of algebra, we look at the bracketed expression first. And in this case, we can turn that into the log of u to the 6th. Remember, we can take those numbers in front and we can change those to powers in our logarithmic expression, and that's what we've done. And then I've also, in this same step, said if I've got the common log of two things being subtracted, I can turn that into one expression, which is the log of v to the 4th divided by z cubed. So I've used really properties 3 and 2. But now I've got the common log of an expression plus the common log of another expression, and that plus can be changed into multiplication by our first property. And so it becomes the common log of u to the 6th times v to the 4th divided by z cubed. And again, that's by property 1. So this would be a very good time for you to try your hand at this in your homework.